Alright, today we're going to talk about what are polynomials and different ways that we can label them. Okay, this will get a nice introduction to the unit, a little bit of terminology going. Okay, so you're going to see a couple charts on here. What I like to do with these charts is just kind of give you examples and let you figure things out a little bit. So what I'm going to do is I'm going to start giving some examples of polynomials and some examples of expressions that are not polynomials. When you think you got it figured out, kind of try to write down what you think a polynomial is, or at least maybe what a polynomial is not, and at the end I'll kind of reveal things and tell you. So, x squared plus 2, that is a polynomial. Not a polynomial would be 1 over x squared plus 2. That's not a polynomial. Nope, don't want that. Let's see, 3x plus 4. That is a polynomial. 3 times the square root of x plus 4. That's a polynomial. Maybe you're getting a better idea of what a polynomial is already. Let's see. The number 5, we could kind of say that's a polynomial. It's a specific type of one. It still counts. The absolute value of x is not a polynomial. I'll give you guys a couple more here. X cubed plus 4x squared minus 1. That's certainly a polynomial. Let's see. 3 plus 2 divided by x is not a polynomial. So what you're kind of seeing is that polynomials are made up of different terms. They could have multiple variables in them too, even x times y or xy plus z. We could call that a polynomial too. Typically we just work with x's in here, single variables, for a while. There are certain rules though that when you're creating a polynomial you just can't have. What you hopefully notice is that you can't divide by a variable like we did in those two places. Can't have the square root of a variable, can't have the absolute value of a variable. So really, in a strict sense, you need variables with whole number exponents. That's all you're allowed to have in there. They can be added, subtracted, and multiplied, and you can't divide by the variables either. I could throw a divided by 2 into this first one, and that would be okay, as long as I'm not dividing by a variable. Okay, now that we have an idea of what a polynomial is, let's talk about how we name them. Okay, so the polynomial x cubed plus 2x plus 1. This polynomial has a degree of 3, and it also has 3 terms. So see if you can figure out where where both of those 3's came from. I'll show a couple different examples, and hopefully you'll figure out a pattern. X squared plus 2x plus 1. This one has a degree of 2, and it also has 3 terms. Let's look at another one. 2x. That has a degree of 1, and it has 1 term. 2x cubed minus 4x to the 4th. That has a degree of 4, and it also has 2 terms. Okay, so hopefully the number of terms you figured out pretty quickly. Terms are separated by addition and subtraction, so I'm actually going to circle what each of the terms would be in each of these expressions. Okay, so that's where the terms part is coming from. The degree is simply the highest exponent on the variable. That's all it is, just the highest exponent on the variable. Now, down here I have a list of some terms for you. You will need to memorize these terms. Okay, you have to know them. This is part of knowing the language of math. You have to get to know it. Okay, so for example, this first one, I would not say it's a third degree polynomial with 3 terms. What I would actually say is that it is a cubic trinomial. Cubic would mean that it has was third degree, and trinomial would mean it would have 3 terms. I could do the same thing. This is one you're going to hear often. Second one is a quadratic trinomial. You can go ahead and label the other two. If you find one that has a number that's not on here, like here we have a degree of 4, in that case you can just label it as 4th degree, but we can still label it as a binomial. Okay, you have to memorize those terms, okay? Definitely by the day of the test. So you got a long time before I'm going to need you to have those memorized, so you've been warned, okay? Last couple things that we need to be able to do with polynomials is we should also know what the word coefficients means. So I'm just going to write out a random polynomial. I'm not going to use the number 3 twice though. Boy, that was silly. Coefficients are the numbers in the problem, not the variables. Okay, so in this case the numbers 3, -2, and 4 are coefficients. So like you could label 3 as the coefficient on x squared. You could label it as the 2nd degree coefficient too, I suppose. That's the coefficient on x. We do need to label it as a -2. Again, that's part of our understanding that that whole term is negative. And where we really like to talk about coefficients, this one we would call the leading coefficient because it's the one that comes first when the polynomial is in what we call descending order or standard form. Okay, so when you see polynomials, typically you will not see them written like the one I am about to write. You will not see them written 3x plus 4x squared minus 5. That's not good form. Typically what we do is we put them in either ascending or descending order of the exponents. Okay, so we could go descending order, so the x squared term, the x term, and then the constant term. That's descending order. Or we could go in ascending order, and we could flip everything around. Now make sure that when you move terms around that have a subtraction sign before them that you keep that negative moving with the term. Descending order is what is considered to be standard form. So I'm going to expect that if your answer in the future is supposed to be a polynomial on a test, and I'm not telling you specifically that I want it in ascending order or anything like that, that you should be putting it in standard form, which means order those exponents from greatest to least. And we'll kind of talk about what happens a little bit more when you have multiple variables in there. So if you have an x and a y, what order do we put things in? You know, and things can get a little bit tricky there. But for right now, that's about all you need to know with polynomials. So try some practice problems. It's just a lot of ordering and labeling and naming today, so not a whole lot for you to actually show me in terms of math. Just a little bit of getting to know the terminology that we're going to use this chapter.